Okay, so now what we're going to do is we're going to look at integrals that involve powers of trig functions, all right? So the first one we're going to deal with, integrals involving powers of sine and cosine. And what we're going to do, we're going to have a goal in mind. Our goal is either to have sine to the nth of x times the cosine of x dx, in which case we have n factors of sine with a single factor of cosine. This single factor of cosine is the most important part, because this single factor of cosine is going to be a part of our du for our u substitution. When we integrate, we're going to integrate as u to the nth du, but this is where the du is going to come from. Or it could be the cosine to the nth of x times the sine of x dx. And it's the same thing here. We're going to have cosine to some power. That's going to be u to the nth. And this sine x factor, that extra factor of sine x, that's the factor that we are going to use for our du. So our goal is to integrate these with the u to the nth du formula. U to the nth du. N is going to be the power of the sine or the cosine. U is either going to be sine or cosine. And du is where that other factor comes into play. So if u is sine, if u is the sine of x, then du dx, or du would be the cosine of x dx. And if u is equal to the cosine of x, then du would be negative sine of x dx. So that's why we have to have that single factor of either sine or cosine in order to do this. And once we achieve what we want to achieve by getting that single factor of either sine or cosine, we're going to turn all the other factors of cosine or sine into the other trig function by using the Pythagorean identity. Sine squared of x plus cosine squared of x is equal to 1. So these are the necessary parts. You first have to isolate a single factor of either cosine or sine. You have to isolate one factor of either cosine or sine. After you've done that, you change all the other factors to the other trig function using the Pythagorean identity. And then finally, we're going to use this rule to do the integration. 1 over n plus 1 times u to the n plus 1 plus c. So these are all the players, all right? Let's go ahead and use what we have just spoken about to do some integration. The first integral I want to look at is an integral that looks something like this. The integral of the sine cubed of x cosine to the fourth of x dx. Now, based on the criteria, what I need is I need to have either a single factor of sine or cosine in order to make my du, so I can do the u substitution and integrate it as u to the nth du. But the problem is, or the essential part of this is you have to look for either a sine factor or a cosine factor that has an odd power. If it has an odd power, you can isolate one of those factors of sine or cosine, isolate one of those factors, and then that isolated factor will now be your du. The other factors, well, there's going to be an even number of them, which means you can apply the Pythagorean identity to them. So what you're really looking for when you're dealing with integrals that involve sines and cosines is you're looking for which one of those functions, either sine or cosine, has an odd power. The one that has an odd power, you're going to isolate one factor of either sine or cosine. In this case, it would be sine. And then you're going to use that for your du, okay? So here's how it works. Since there's an odd power for sine, remember, that's what you're trying to locate. You're trying to find which trig function, either sine or cosine, has the odd power. Once you've identified the one with the odd power, then you're going to isolate one of the factors of sine. So this is what we're going to have. We're going to have the sine squared of x times the sine of x, that's the factor I'm isolating for my du, times the cosine to the fourth of x dx. So all I've done is I've written the trig function that had the odd power. I've written it as a product of the even power and the extra factor that we're going to use for du. Okay, so we get this thing. This is great. All right, so since I only want one factor of sine, I'm going to turn all the other factors of sine into cosines using the Pythagorean identity. Well, the Pythagorean identity says that the cosine squared of x is equal to 1 minus the sine squared of x. Oops. That's not the one I want. I want the one that says the cosine squared of x is equal to 1 minus the sine squared of x. So that's the one I'm going to use. So I'm going to change these extra factors of sine that I don't need, because they're not going to help me with my du. I'm going to change them into cosines. So this is going to become the integral of 1 minus cosine squared of x times the sine of x times the cosine to the fourth of x dx. Okay, now I have this difference inside of this parentheses. What I'm going to do is I'm going to distribute the sine cosine to the fourth of x dx, and I'm going to integrate each term separately. I'm going to be left with two terms. Well, the first term, if I distribute all of this to the 1, I get the integral of the cosine to the fourth of x times the sine of x dx. And then a minus sign, and then I'll have the integral, and this one is going to be, well, cosine squared of x times cosine to the fourth of x is cosine to the sixth of x dx. Oops, and I forgot the sine of x dx. Okay, once I have it written this way now, you see that this integral here, this integral, if you let u equal the cosine of x, then it turns out that du dx, the derivative of u with respect to x, is going to be equal to the negative sine of x, which means that du is negative sine x dx. So I have everything I need for my du. I have sine x dx. The only thing I'm missing is that negative. So I'm going to put the negative in. I'm going to put in the negative, and I'm going to put a negative on the front side of the front of the integral in order to balance it out. So now this integral is exactly u to the nth, n is 4, u to the nth, and this whole thing right here is du. The second integral, once again, it's the same thing. If you let u equal the cosine of x, then du is equal to negative sine x dx, which means I can modify that. I need the negative, so I'm going to put the negative in as long as I put a negative in the front, which changes this sign to a plus. So now this is what I'm integrating. I'm going to do the u substitution now. This is negative integral. This is u to the fourth power. This thing right here, well, that's du. Then plus, right here I have u, the integral of u to the sixth power, and that thing right there, well, that's du. So this integral I can do using just the power rule. So this one becomes negative 1/5 u to the fifth power, and this one becomes 1/7 u to the seventh power, and I still have my plus c. And then all I have to do now is back substitute. So the final answer for this, let's see, that's negative 1/5 u to the fifth. Well, u was the cosine of x. So u to the fifth power is the cosine to the fifth of x. So that's negative 1/5 u to the fifth. Then plus, then this one is going to be 1/7. And remember, u was the cosine, so this is cosine to the seventh of x, and then plus c. So here I have integrated it. And all I've done is I've identified which one had an odd power of either sine or cosine. I isolated one of those factors, changed all the other factors to the opposite trig function. Then I used the factor I isolated for my du in both cases. Do you see that? The factor I've isolated is du in both cases, and it turns into u to the nth du every time. And then you can do the integral just using that u substitution. Let's try one more. All right, now let's say we want to integrate something like this. The integral of the last one, the sine was to the odd power. So let's make cosine to the odd power this time. Let's say we're integrating cosine to the 5th of x dx. So you identify which one of the trig functions, when they're factors of sine and cosine, you identify which one of the trig functions has an odd power. Since it's only cosine and it has an odd power, that's what I'm going to isolate. I'm going to isolate one factor of cosine. So I isolate one factor of cosine by making this cosine to the 4th of x times the cosine of x dx. Well, that's great. Now I see this has an even power on it, so I can apply the Pythagorean identity. This is actually the integral of the cosine squared of x squared times the cosine of x dx. Why? Well, when there's a power on the inside and a power on the outside, you're raising cosine to the square and to the 4th, or square and to the square on the outside. You'd multiply the power, so these two expressions are equal. These two expressions are equal. The inside part, you can use the Pythagorean identity on. So the inside part becomes, well, the Pythagorean identity we want to use is that the sine, the cosine squared of x is equal to 1 minus the sine squared of x. So since we have a cosine squared inside of this parenthesis, we're going to change it to 1 minus sine squared of x. This is going to be squared. So I change the other factors into sines. And then I still have my cosine of x dx. That still stays the same. Okay, now, this thing right here. Well, I can FOIL that out. And I'll get, let's see, 1 minus 2 sine squared of x. And then it would be plus sine to the 4th of x. And this is still times cosine of x dx. So now everything else is a sine, and the factor that I isolated, that single cosine factor, is going to be my du. Because if I let u equal sine, du is going to be the cosine. So let's go ahead and do the distribution here. So I'm going to get 1, 2, 3 different integrals. Let's see, the first integral is just going to be of the cosine of x dx. The cosine of x dx. The second integral is going to be negative 2 times the integral, and then this is going to be sine squared of x, and then I'm distributing the cosine and the dx, so it's going to be of the times cosine of x dx. And the third one, then plus, this is going to be the integral of sine to the 4th of x times the cosine of x dx. Okay, so if you look, I have 3 different integrals for each of these 3 terms. This integral right here is just of the cosine when I distributed the cosine to the 1, cosine of x dx. This one here leads to this one. I'm distributing the cosine. That's the du I need. This is now u to the nth du. And the last one is when I distribute to this one, that's the sine, which is u to the 4th du. So let's do that u substitution. So now that I have it rewritten, this is the u substitution we're going to make. I'm going to let u equal sine in this case. I'm going to let u equal the sine of x. In that case, du dx is equal to the cosine of x, which means that du is equal to the cosine of x dx, which is perfect. I have a bunch of cosine of x dx's for my du's. All right, now I'm going to actually do the substitution. Well, let me see. This one here, well, that's just du. So I get the integral of du. That's just the integral of du. Then I have minus 2 times the integral, well, this is u to the nth, where n is 2, du. So that's u squared du. And then the last one, plus the integral, and then this is u to the 4th du. U to the 4th du. So I'm going to do all these integrals. When you integrate du, you get u. When you integrate negative 2u squared du, you get negative 2/3 u to the third power. And when you integrate u to the fourth, you get 1/5 u to the fifth, and then this is plus c. So here, this is the integral, but it's in terms of u, and I need it to be in terms of x, so now I'm going to back substitute. Well, u, we said that u was sine of x, minus 2/3 times u cubed, which is the sine cubed of x, plus 1/5 of u, which is 1/5 of the sine to the fifth of x, and then plus c. So this is the final answer for that integral. So you see, what you're doing is you're looking for which factor, either sine or cosine, has the odd power. That's where you're going to isolate your du from. Notice what you're doing is you're isolating the du. So once you've isolated the du, you change all the other factors to the other trig function, and then you distribute everything. You should be able to integrate using just the power rule, u to the nth du. So that is how we're going to deal with trig functions that involve odd powers of sine and cosine. So this is for integrals involving odd powers of sine and cosine.